Now how cool is this? I have a day that I have to make bell cranks up. I'm basically stuck here. You can see I've got this is going to be a whole day, but guess what comes in the mail? A new video from Al Rabe showing his Millennium Mustang. Loads of neat little new stuff. See, this is what's nice. Even when you're windy, I don't know if that's good or bad. We have our silver over here drying, cooking up by the vents. There's still too much snow to even think about going out and doing a break-in. But how nice it is to have video from long ago, far away, or this is even new video. Something when you have a redundant modeling job that just takes hundreds of hours of just sitting around doing things, we just got to do hundreds of these. It's just terrible. But having some video from Al, they really appreciate it, and it really does make the time go by. This is a pretty creative thing that Al's done with his new Mustang. I really am impressed. Loads of little different new things, little jigs to hold things up. Always interesting to see how other people, they challenge themselves and they come up with solutions to problems.
Anyway,
one thing neat on this is Al's talking about, and I'm just watching this as I go, some of the neat things how he modified the Millennium Mustang to, the little changes he made to the design. Very thought-provoking. Showing the plans to a Corsair that he drew up at one time. Boy, Molinex, eat your heart out. Molinex is doing a Corsair. There's some cool stuff. Al's new plane is 10% bigger, and he goes in complete detail about how he upscaled and moved the wing, and he had some views of this where the new one was next to the old one, and you could see how much bigger the one was than the other one. And if anybody really is going to build an Al Rabe Mustang, this video would probably be a must-see. A lot of little techniques, and you can always, the thing I always emphasize to you can learn from everybody. You certainly, by sharing the information, how neat is it that you can have video of this and use some of these ideas in your own, you can see how the one that's not finished is the Millennium Mustang, how much bigger than the original one it is. I look forward to seeing how these guys fly. He's shooting for 62 ounces with a PA. Hey, this should be a neat plane. And thanks a lot to Al. Now today, what I wanted to do, I wanted to kind of finish up this test Nomex piece that we made. We did this more as a materials test than for any other purpose. And the reason is many people have thought of the idea, including our friend Lyle Larson, of eliminating the carbon altogether and just using this tight weave e-glass. Well, in the past few days I've gotten some even lighter material from George Spar, and because we're getting ready to lay up fuselages, the reason I'm trying to do dedicated days, I want to get a dedicated day to work on that fuselage. I don't want to be doing it in bits and pieces like I work on these other projects. But anyway, what I wanted to do, I wanted to trim this all off, measure it up, trim it, put the edges on it, and kind of get this ready. Woody's kind of excited about coming down here to assemble this plane. And since the wing and tail are done, the wing is done and flaps, I'd like to see if this is going to be a practical way. If not, I'll just make him up another one. But we'll use this one. You always need a little guinea pig part to try to just see if these materials are practical. Now, the original part certainly wasn't, perfection. We weren't trying for perfection. I wanted to the couple of things that I wanted to see is just get a rough idea about the weight. Now, I know, because I can see how strong this part is, that for sure I don't need to make it this thick. But because we've already made this piece and we already have it, it'll be good to have, once you complete a test part, then you can look at it and say, well, how am I going to make this lighter? Well, we could use, this is 3.3 ounce, we could use 2 ounce. We could possibly take the Nomex down to 1/4 inch. But until you make the first part and get some idea of how strong it is, and it seems relatively strong, you don't really know if it's going to be a practical way to build. Next thing I wanted to do, of course, is mark a center line, because we didn't make this, we made it oversized in every dimension. And I want to go over and trim this off and run it on a belt sander and get all these edges relatively as equal as possible. And I want to make sure that I have a center line that I'm working off for the center here. Because what you could do with this, when you make a sheet of this, you don't need to make the shape of the tail. You can just make a big square piece. And then you can cut tails and elevators out of it if that's one of the choices. But again, we're doing a materials test to try to find out if this lightweight e-glass is going to be able to, in some of the lighter parts, eliminate, and it's the carbon fiber that makes this really expensive. If we could eliminate that $100 a yard carbon, we might have a much broader range of things that we can use this for. Now usually in the past, whenever I've cut Nomex, once it's cured and post-cured, it cuts relatively, well, not relative, cuts reasonably. And if you've ever cut carbon fiber, you know you get about 2 cuts and then you replace the blade. And the last little bit I'll do on a belt sander, I'm trying to leave about the thickness of a pencil line. I'm trying to get cleaner edges, just tended to be a little bit ratty. Okay, now I know from this center line out I can measure and cut the tips. I'll lose a little material, but it doesn't matter. We're going to just put flat tips on this anyway. Again, it's a test model for a test piece. Found from our illustrious wood supply a piece of decent sea grain that scrap was left over from, and I found that this is a good way to attach Nomex parts to either trailing edge or leading edge. Is first get some, this is 80 grit sandpaper, and just make dust. Make plenty of dust. The dust helps kick the CA off. Leave the dust right in position. It's a good little trick, by the way. Leave plenty of room on each side since we're going to cut it off. Now I'm on a flat table, so you would think there's some chance in the world that I'll have a flat surface when I'm done. And because it's sea grain, it'll tend not to warp. And I can hear everybody out there saying famous last words. Anyway, in a long conversation I had with Midgley yesterday, he's finishing up on having our bags for making the fuselages. That's the last piece of the puzzle, and we can make more fuselages. And let's hope this one works. Now, I'm not going to kick it. I'm just going to let that sit. We'll give that a minute or so. Keep it under pressure. Of course, what I want to do is leave on just a little bit of material, and I'll do the final sanding with a sanding block. Use a cutting pad, makes it just a little bit easier. I was surprised how well, the first time I did this, how well the CA seemed to bond Nomex parts to balsa wood. So that was one of the real positive things. I'm just trying to, this is some 80 grit paper, just roughing this in. Like I said, I think I'll answer the phone. Thing about the epoxy, this is the E-Plun, it's sand, and I block sanded this out, but you can see there's still little moon craters in it. But it's sanded the joint where the balsa wood meets this. It's really kind of, just show real quick, well, it doesn't matter, both sides are the same. I'm trying to find a spot so I wouldn't have to sand it twice. But the trick is to not go down into the Nomex and yet get the moon craters out. And what I'm always amazed at is when I do this part of the operation, how much weight. Basically, you can almost cut the weight in a third just with light sanding. But you got to be careful. As soon as you see any hint that the Nomex might be coming up, your party is over. And again, because it's a test plane, we're not going to try to put on the ultimate finish here or anything. Notice in little spots like this where I've just gone a little bit too far, I can just hit this with some thin CA, let it dry, sand it out. It's kind of like a little instant patch. See what happens, the little moon craters where you have where you've sanded. Of course we're going to prime that, that'll definitely go away. I have some nice 3/8 wood. I originally thought of making a molded leading edge, but because this is a test part, and we just want to get it in the air. We're just looking to get this in the air as soon as possible. I'll basically do the same thing, making up a leading edge, and that'll give me a leading and trailing edge to work off. I could, if I really wanted to, again, the way we make the molded leading edges, especially the laminate ones, it would be easy enough to do, or I could take and make I was thinking of some other ways to do this, make a mold for a reverse piece, so it would be composite, but for this small amount it doesn't even matter. And we want to get this, the objective here is to get this plane in the air this spring and see how it's going to fly. What I'll do is zona saw this off and then of course just make the other part. Do is when I join this piece, make sure I get a nice joint up here. Now the next thing, I'll just make the curve for the leading edge, and then I want to put some little tips on this and then give it a final sanding. I'm sure if we were making a contest model, we just spend a little more time on the fix and finish here, but to make a serviceable part without spending a lot of time, because I still have a lot of test parts I want to make. And no matter what the part is or what the material is, you can always spend the time to put a nice finish on it. But see, what's nice is that blends right in. Almost instantly with a sanding bar, because you can work off of the surface. Now when it comes time to radius this, I'm not even going to make it too fancy, you won't even carve it, just knock it right down. You can hear as soon as you go into the, again, you can even take this leading edge off and make a mold if you wanted to, but curve right in there. Last thing is just to put on some flat tips. Now because it's a test model too, we're just going to put on some 60-foot plywood tips here. Sand these in and I get a quick finish. We're using up some of the old CA. I always use up old CA to do this operation. Just take a paper towel and we want to get a quick dirty finish on this. And usually that's enough to, oops, don't hold it steady for any length, and that's usually enough that you can go right to primer. And what I want to do, just for my own satisfaction, I didn't really do a thorough sanding on this, because what I'm going to do is try to put on a coat of Rodak primer. And as I'm sanding a primer, sand down into these little valleys and pockets, and this looks on camera like this is all rough. It isn't. That's what's inside. The surface on this is relatively smooth, if you can see it. It just looks kind of ugly when you see the, and again, it doesn't have to be pretty under the paint. I want to see if this is going to take 1 or 2 coats of primer, 3 coats, and while this is drying, then I want to work on my elevators for this project. Again, this is a good thing to work on while we're letting our silver dry in between coats. That may need 1 or 2 more sandings. I don't know, but giving it a couple of days and working on some other projects just seems to break up the monotony of doing this kind of work too. You got to realize we're doing this, between 12 and 14 hours a day at some point in time. Anyway, let's get some primer on this. Hold it this way because eventually we're going to put the horn in here and slot this all out, so that'll just be, I've got to try to get it right on center too. Give us a little handle while we're spraying it. I'm not sure if this is going to take 2 or 3 coats, but I know the wood parts usually take a few more. But because it'll fill in all the little dimples and everything, and then we'll be able to really sand it down. I'm afraid if I sand it now, I'm not going to see it. I'm not going to see that initial thing of it coming through. It really won't matter how much of this we put on because we're going to sand it all off anyway. Now you can see one of the things we have is a couple little fish eyes in here. I'm going to go put some fish eye killer in the primer and then come out and shoot right over this, and that'll kill the fish eyes. Anytime you see those little, let's see if we can show them, those little fish eyes, that's from silicone, something that was contaminating the final, sometimes it's in a sandpaper even, and you sand it right in. Fish eye killer will get rid of that. A good little trick that'll work every time. See how we still have some contamination here. There's little fish eyes. And on this side I repainted it. But what you can do is just take an old paper towel, wipe the material right down in, just scrub it right in, throw the paper towels away, let that dry a few minutes. And what that does, it fills in all the little fisheye pockets. And if you do it just as that's pretty cold out here today, so it's probably going to take time to dry. It's a good little trick when you're doing up composite stuff. Now Lyle Larson had a great little tip when you're doing, I just talked to Noel Drindak this morning. He's painting up these wheel pants he bought that are made out of polyester resin. And Lyle's trick was just take ordinary old spackle and just rub it right in. Let it dry, sand it off, and that gets rid of it. Now I'll just let this dry before I repaint it because it's going to be in all, see you can see it's in all the little spots, all the little dots and dimples. Just let that dry and then we'll repaint it. Now while our primer's out there drying and waiting for all those fish eyes to close up, one of the things that I'm not sure if I'm the only one that's ever run into this, but when I try to do 2 sheets at the same time, I find that the top sheet of Teflon usually has a lot of dimples in it from gravity, while the bottom sheet is a lot better. So I thought one of the possibilities I can do is, and again, this is what we're trying to learn, the technology, is I could lay up half of it. See, I'm just going to lay this half up. I'm going to do this with a balsa frame. I want to make, since the elevator is a constant cord, the 3.5 inches, I'm just going to make a leading edge, 1/4 inch wood, a trailing edge, put in some geodetic ribs, balsa wood. But now I'm going to take that frame and use that frame to lay it in one side of the carbon. Now, once that dries, see what will happen is the gravity will be my friend here. Everything should lay down flat. Now, once it's dry, I can turn it over. Picture how this would work. And I can lay the carbon wet on this side. See, it'll take 2 days to actually do this. But the reason I want to try it is I'm just not happy with the way the surface is. The bottom surface, if you will, is nice and flat because it's on a flat surface. Even though there's a flat piece of glass or some other flat surface here, what happens, gravity in between all the little pieces of Nomex or the pieces of rib or whatever tends to bring that down. So you have two uneven surfaces. And since we're not in a rush and we're just doing material testing, we want to try to see if what it really is a fair test here. So what I'm going to try to do is make a half. Lay the Teflon sheet down, 2.94 carbon, wet with resin with EPON, and then lay my framework, and I'll make the frames ahead of time. Just simple balsa construction, because what I want to see is, see, the Nomex, it'll be fun to see if a Nomex part, we know what Nomex parts weigh, and it'll be fun to see if the balsa parts are lighter than the Nomex. Now, if that's true, then needless to say, that opens up a whole nother door to making flaps and elevators. But right now, we know we can make Nomex elevators. We've already made Nomex flaps. So what we want to try is, and it's really just a test for us, and I'm not so sure, even in doing Nomex, that bottom piece, if I could show this, and in Nomex, the little cells come down, what happens is on the bottom piece, that little extra resin tends to gel and you get a nice bond on that side, but on the top side, the resin just, you don't get anywhere near the type of bond. Now, the thing would be is halfway through the layup, take the part out and turn it over before the resin gelled. I don't know, that's one possibility. But we're looking at ideas, we're looking at possible ways to do things, and an elevator, especially for a test plane, that we're basically going to use it as a rent-a-plane all summer. This is one of the tests I would have to do to kind of make myself convinced that we're going in the right direction, or there's no reason we can't make these little shells out of balsa wood, because it's the skin that'll be on that carbon skin that would, in essence, make it really, really resistant to warping as opposed to silk span and stuff. Having that piece with the shape right in it, either flat or curved. And of course, if this works out, it just gives us more possible ways of doing things. But having that carbon skin and laying half up at a time, it's going to be an interesting test. One other thing that I'm real interested in trying, and maybe we'll try it on these elevators, is when I have a carbon skin part. What I've noticed is, when you put the primer on and sand it off, the thickness of the primer is one of the things. To get a proper coat of primer, it seems like it's 2 or 3 times thicker than the equivalent amount. And I've got the marine primer and I've got Brodite primer. They both result in the same thing. They really put a thick coat before you have a really part ready to finish. Well, I thought it'd be worth a test. And believe me, I'm just fishing for ideas here. I'll take ideas from anybody. I was wondering if we didn't prime it at all. If we just took the next carbon piece we make, or a test carbon piece, and put 1 coat of Brodite clear on it, since it doesn't have to sink into wood grain, it would all stay on the surface, and take some medium grade silk span and put it right on top of the carbon. So that in essence what you'd have is a thin carbon skin, and the thickness of the tissue once it's sanded is almost immeasurable. It's in such a thin amount. So I'm thinking this might be another way. One of the areas, like even on Miss Ashley, that we picked up some weight that I thought was unnecessary was in that primer. So again, this is one of the things. While I have experimental parts, and what's nice is if these parts don't work out for whatever reason, on an experimental plane, we'll find out when they break, where they break,
where we're gaining the weight, where we're losing the weight. One of the things, when you pull a carbon fiber piece out of a mold, and you could sand right down into the carbon, then it's always prone to get those little fish eyes. So maybe another thing, like with a ring, would be to sand right down. I mean, grind right into the carbon and then put a coat of tissue on it. Another thought had occurred to me, these are just ideas, is to lay a piece of silk span right in the mold over the Teflon, then lay the carbon in, then lay the Nomex in. See, if you don't have, first off, you need the ideas. If you don't have any ideas, and of the ideas that are possible, you need to sort through them and see which are the most appropriate. But we're going to be doing a lot of testing, because in the final product, what we're looking for is to make this as doable for average modelers as possible, and not make it a Boeing project, make it something that pretty much everybody can do. Before I ever work on this table, doing anything like a layup, or laying out sheets of Teflon, there's always little things that I need to clean up. Oop, there's some real piece up there. You never know where it is, but this is all stuff when you're laying up a part. First thing I'm going to do is lay my Teflon sheet down on the table.
One other thing this is what happens. You get a train of thought going, and I'm thinking, Larry Cunningham has been excellent giving me all kind of ideas, thought-provoking ideas. Because when you're doing something that's totally new, you never know where that answer's going to be. It's like forensics. You never know where you're going to find the answer. Anyway, I'm going to use this sheet of glass, which you pretty much can buy at a garage sale. I seem to wind up with plenty of sheets of glass. Other people say they have trouble finding it. I'm going to lay down a piece of Teflon sheet. Wax paper, by the way, works almost as well. Good enough, certainly, for our purposes. And then what I want to do is, I want to make up that little frame. Since these are constant cord elevators, which means they're the same at the root as at the tip, I won't have to take into account any of the taper. I can just make them, I can have them either dead flat or some combination of flat. Okay, now I need to strip off some wood. I have still a piece of sea grain, 1/4 inch. I want to strip off some little 1/4 inch pieces, 1/4 by 3/8. Now it's real important when I make this pseudo little framework, try to use all sea grain. Of course, try to keep it as warp free as possible. By the way, good idea. Always put a little block of wood over the blade. Many times I've had this sitting here and walked there and hands get chewed up enough without having to do that. Okay, so I want to lay out the elevators are 3.5 front to back. I'm not going to allow for a leading edge. And I'm just going to make the equivalent of a little box frame. Again, this is just a test. This may not work. But if I don't test some of these ideas and see where the gain and loss is, I wanted to see if that carbon fiber skin can be supported between ribs without having an Nomex behind it. And if this doesn't work, I'm just trying to think. This is the outline of the elevator. We can true this up later. I'm allowing for a little bit of a, since this is 1/4 inch and the stab is 3/8, there'll be enough of a wash in it. Now I just need to lay out some ribs in here. I'm trying to lay out some reasonable spacing here. See, I'm interested in knowing, and of course, most of the time when you do testing, it fails. But the 1 or 2 times that you do something and it really works nice, well, make these pieces 1/4 inch rather than doing 1/8 inch ribs, because I want to have a lot of footprint out onto the part. But it's so true when you're going to do some experiments, you can't think every one is going to work like dynamite. You got to be prepared for some failure. But what I do is I use up time in the shop that I'm either waiting for something to dry or something to who knows what. Late at night time when Karen's already asleep, so
And a lot of times people will tell you something, and it's not that they're wrong, it's just that they've experienced it totally different. They've tried that thing that you're trying, but they haven't been able to make it succeed. So a lot of times it's just better to do the test yourself if you really want to know, if you really want to be an innovator. Now what I'm going to do with these stripped off pieces, I'll do this, and they're plenty thick. See, I'm not trying to make them 1/8 of an inch. I want to lay these out and make geodetic ribs on these. So now once you have this laid out, what's nice about working over Teflon, you can just tack glue it together. And it doesn't glue itself to the table. As I said, sometimes it doesn't glue itself to the table. No, it never does. Now I want to cut some 1/8 inch pieces that'll be the geodetic parts. Stripper is still set to the same dimension. I can strip off some scrap. Now, you know, some people, I understand, they don't want to do any testing. They want to just basically build a plane. Well, that's certainly nothing wrong with that. But for the people that want to constantly upgrade, change, I don't even know how to define that. I wish somebody'd come up with a good definition. When you want to pioneer new ways of doing things, well, sometimes you have to be willing to make a few parts that don't work out. In this case, if this doesn't work out, I always have to keep reminding myself, it's okay. Not every part has to work. Now, I'll just set these ribs in place. This is pretty straightforward. And then I need to make up another. The reason I'm going to make 2 of them is because if it works, I want to be able to do the other skin tomorrow, and in 2 days I have the elevators and the stab and the primer and go on to all the next steps right after that. Want to get this is the surface I'm going to work off, flat as possible. And this will be an interesting test. I don't have a lot of high hopes, but it'll fill in an hour of tonight when I normally wouldn't be able to do anything except except watch television. Not that we ever watch television here. And this, it's irrelevant what kind of frame you use, but what I want to see is how that carbon is going to bridge the gap. But it's only going to be in the gravity mode. If I were to do both laminations at once, the top one would sag, bottom one would be flat. So this will be interesting. Last step, I want to make sure these are perfectly flat. I made 2 of them. I want to make sure they're perfectly flat and that I don't have lumps in the glue joints. Again, I guess this is, a lot of people would find watching TV at night very interesting. What I find is, well, I don't know how to describe this. Finding out just what the possibilities are with using these products that we've at least been introduced to in the last 4 or 5 years. I know there's more I can squeeze out of this. Here's the other one. And they're ready to do the layup. Now what I wanted to do, I wanted to lay out the dimension here, because we're going to put the aluminum tubes in on the end, of course, when this is done. I need to cut off, because we're not going to have tips. I had measured this thinking we were going to have some kind of fancy tips here. We're not, so I'm just going to trim that last bay and move that piece in. And of course, I'm going to answer the phone. Put in some cross-grain reinforcements because we're going to obviously drill a hole there or sink the tube into the end. I want to lay up the cloth now. Again, this will be, I hope, a very interesting experiment. If it isn't, we'll make elevators with Nomex. We know we can always replicate this. What we're trying to do is constantly move the bar up a little bit each time.
And one of the things I save, believe me, at $100 a yard, you don't throw any scraps away. And here's a good example. Now see, you're not going to get two pieces out of this, but I have a scrap. And the reason we haven't made our other fuselages is we've ordered more material. And obviously, this is delivery of composite materials is not overnight. It's just leave it at that. Okay, we can't even get a double piece. See, we've run into a problem already. Maybe this piece will be long enough. But this is always something why you save every scrap of this stuff. Well, you never throw one quarter of an inch away, because you never know when you're going to need a test panel. Now, there's one. There's two. We can make them a little bit bigger. Voila. Pretty cool. Okay. What you can do is when you have scraps, even small pieces, you can chop it up and make carbon powder out of it, or pulp. But anyway, we do have a piece. Now what I have is the piece of Teflon taped to my glass. I'm going to mix up some resin. This will be Epon. Put a little bit of the haloxy modifier in there. Trowel it all out as nicely as I can. So I'm going to try to get the weave even matching. Have enough room there. And tomorrow when we come down, we may have elevators.
An important lesson we learned is never stir the epoxy with a wood stick. So I don't know how many variations of Epon that holds for, but it holds for 862. And once I get this mixed, and I think it's mixed, mix it another 2 minutes. And I'll do that off camera. I'm trying not to, even though this is not going to matter to put air bubbles in it. This is just for my own reference anyway. Anyway, because the temperature in the shop is cold, this is going to take a little bit extra time to set up. I want to make sure I wet this, because I'm working to get both sides of this wet. And then we're going to try to trowel up all the extra. The tape, the green tape, just holds the Teflon in place. And of course I want to be sure I don't have any dry spots. Now what I thought I'd do, and put this on camera, because I know several other people are working with trying to make Nomex type of flaps, and people like Larry Cunningham, John Grigsby, everybody seems to be able to put one piece of the puzzle together, but so far I think we still have some pieces to put together. I've got plenty through there. Now see, this is the part that is squeegeeing out all of the extra resin. And I'll be very interested to see if this is going to support between ribs the way I'd like it to. See, it's the resin that weighs. It's not even the cloth. It's that you have so much weight in the resin. The trick is to be able to get rid of as much of the resin as possible. Now, one of the things we could do if we could justify the expenses, make up a couple of pieces with pre-preg, but then you're getting way over $100 a yard. You're up in big money, and you've got to pay for the shipping, the overnight shipping and everything. Now we've got that pretty well done. Now what I wanted to do is take each part, and the side that's going to go down, I'm going to do it with a brush. What I'm trying to do is get just a thin amount evenly spread on here. When I think back of all the trials and tribulations of putting that Miss Ashley body together and having to make two of them, but boy, when it's done, you get a feeling of satisfaction.
Okay, now, let's see if we can just drop this in here. And I want to see that I have I think you can figure out what I'm looking for here. I want a good bond. Now I'll get the other one in here off camera, then we're going to put this aside to dry overnight. I'm just carefully putting the cans on, making sure we have a good footprint. We'll put the rest of the cans on there and we'll be all set. And we'll be back to this tomorrow to see if it worked. Now I always can't wait until the morning of taking some of these tests apart. There is always a certain excitement. Now because we laid this down on Teflon, actually it ought to come right up. Sometimes it doesn't though. Uh-oh. It's always good to pour it up slow anyway, you just never, oh, there we go. And we've picked up of course it's going to be sanded anyway. And one of the comments I heard is, a couple of people have already said, oh, you can see all these little dents and everything. Yeah, it doesn't matter in our case, it doesn't matter, because this part has to be sanded for sure. And like any, in fact I got some hairs on it. If you wanted to, you could take a piece of perfectly laid down, actually you could take glass and put PVA on it, we've done that already, but the Teflon just gives us a little easier way to work it. Now I want to cut these off with the scissor, and then I want to do some shaping and sanding here, and then I want to reverse this and let this sit for another day with the other side on. But I think you can, even looking at that from far away, you can see that's taking up a pretty nice imprint. But of course the imprint, we don't care about. This needs to be sanded. And again, this is not the surface we're looking for, but we've certainly got plenty of material, plenty of resin on there, so we can sand that smooth and put a finish on. And usually I take my special carbon fiber cutting scissors, and I can trim the whole part like that. A couple of things that seem to work good. We seem to have a pretty good bond between, and I didn't know if we would, between the actual part and the wood. But because this is now a solid surface, or relatively solid, what I'm going to try to do is with my big sanding block shape this and put a little bit of a taper in it rather than having it just a flat part. And the only reason for doing that is to see if I can do it without a problem. Now, because we don't have the box completed, once this side is on, this will get a lot stiffer. Actually, I don't want to bust it. I don't want to hear it snap. It's really pretty stiff even without the last piece on, but I guess we're going to find out. But now if we were going to make a final finished part on this, see, what I'd want to do is get some of these little dimples and chads and everything out of here. But of course this part's going to get totally sanded down. Nice and light anyway. But this will just give us, if we see how this works, we'll have just one more idea of, if this is going to be a practical way to do it. Now you can see how well we've got the resin gravity. This is what I wanted gravity to do. See, what happens is when you have this side on the same as the bottom, the top looks like this, and the bottom, the part that you're not going to see, looks like this. So that was my first concern, whether we were going to be able to squeegee out all that resin, and that looks like we really did a good job of doing that, by the way. This seems to, and again, a lot of times you find little problems that you did not anticipate. I want to even off, there we go, even off the carbon here before I do any tapering. And you can see it's got a little bit of a lip there. Well, I wanted to see how easy that was going to be to dress off. That's not a problem at all. If I try to keep separate sanding blocks for doing carbon. In fact, one of the things I do is I keep a separate box for the sandpaper that I use carbon on, because I don't want this. See, what happens is, if you didn't want to see that, the dust gets on everything, and of course it's a good idea to wear a mask anytime you're not shooting video and just sanding carbon. I have learned the value of having a separate box just for the sandpaper, especially with other people working in the shop, and they throw a piece of that sandpaper in with the non-carbon sandpaper, and it just, everything starts turning black. Your fingers start turning black, your nose turns black, the vacuum cleaner turns, the bird turns black. This is a good idea. Keep that sandpaper separate. Every piece of that sandpaper, you can see what happens to it. Working with carbon fiber is just messy at best. To just rough this out, I want to just put a slight taper in this. Now you could do this with the rod method, putting the rods around it, but for a test model, this will certainly be accurate enough. Now what I'm really looking forward to seeing is when I complete the box, because it's always when you put the fourth piece on the structure that a lot of things, like an I-beam wing for instance, they're real flimsy until you complete the box or get the tissue on it, or in essence just complete that whole circle. I'm not sure how much I want to take this down, but the last thing I can do is and because they're constant taper elevators, very convenient, you don't have to worry about building a twisting. You can't do this with constant taper elevators. With taper elevators, I'm sorry. Now, even though you could use the piece of Teflon over and over, I've decided to put a new piece. It had a bunch of little imperfections in it. Try to make this a little bit neater on the next thing. Now I need to, needless to say, repeat what I did yesterday. Lay out a piece of carbon, mix the resin, lay these in this dimension. Let me get the dust off them first. I have the taper in here. And of course you could put almost any taper in here. And once this is done, I'll add a little triangle piece to the front, try to round off the back. I'm trying to put this in perspective here, because when I'm done, the thing I'll have is a surface that I can't stick my fingernail in, and it should be relatively twist-free. We're going to find out. Now I'm doing the same, pretty much ready to go now. I'm never satisfied that this is mixed up enough. I don't know why. I always give it an extra couple of minutes. Anyway, I'm going to repeat the same process that I did last time and try to get this to stick. Get the brush. Now what's unique about today, this is going to work out well for me anyway, I hope, is I'm going to have some time while this is drying to do a couple other little test projects in the shop that I've kind of put off. And it's just the ultimate in multitasking, getting something drying, getting this drying while I can work on some other projects. It's what I always, well, what I like to think I do well is get the things all running in order. Now it looks like we got a pretty good print through on the original part, so I'm not going to deviate from the way that worked out. I'll just squeegee off as much of this resin as I can. And it's always nice on a shop day to get something drying or cooking, and then I can work on these other little detail things. It is really frustrating to get a job started and know that, whoops, now we have to wait for that to dry and before we can go on to the next step. Always good to have 2 or 3 projects going on at the same time. Now I want to do the same thing, and this is probably the key part of it, is getting this to bond.
Now, one thing about these resin systems, some of them bond to wood real well and some don't. This one seems to bond real well. Now, the idea of this was, and I thought this was the key part of it, because I know the other people that are experimenting with this, somebody's got to hit this sooner or later. I want to see the imprint of this part, so I know I have a good bond. Okay, now I can. You can see how much getting off all the extra resin is the key. I think it is, and Ed Gallagher seems to think it is too. Now keep in mind, the first person that ever made a foam wing, you know, they didn't have a world-setting first foam wing. In fact, it was years before they figured out all the little kinks and tricks. And thankfully, that's one of the things that in our hobby contributes to the fact that a lot of people can participate at a lot of different levels. I'm getting the rest of this off because I think this will be, and squeegeeing out now this last little bit. This is where I guess you could just roll it out too. Dennis Choate has told me you could roll it. See, you can even get, it's amazing how much you can get off of this. And the reason for doing it on two different sides is I want gravity to work for me here. What we're trying to accomplish is to get gravity to do its thing. Let's just see how this works. You can see you just never, there's almost an endless amount of resin you can get off of here. But the part that's, now look at this, is even more. You can get an idea how much is coming off. And you need just enough to fill a weave. And this is tight weave carbon. And I have a feeling that people like Larry Cunningham, who likes to use e-glass, you could probably do this at not much difference in weight. And because we're overbuilding, the strength is so much over what you need. It's just crazy. It's the fact that we can't make it thinner and lighter that's the problem. But that's coming. Okay, now I've got that's about as much as we can get off of there. Now I want to look at my part again. I've got a little spot in here. I can get the resin out. See how the resin dripped in there? Just extra weight I don't need. Okay, now I want to do see if I can get this imprinted in there well. And of course this will have to sit up by our heating vent 24 hours, and even then it's got to be post-cured before we get the ultimate strength. To accomplish here is that gravity is going to be my friend and pull that resin down. And the opposite, now if we were doing these both at once, this resin would want to drip down in there. Anyway, I guess we're going to find out. This has to dry overnight. I'll put the cans of Brodak dope on there and put it up by a heating vent. So we got that up right under our heating vent where our silver's drying. And that's going to sit there for the remainder of the day. We'll work on that tomorrow. Now, the last session I had, I sanded off all the primer. And I tissued this just to see if the tissue was going to be, you can see where I've trapped quite a bit. I really should have sanded more of the primer off. I just wanted to see if the tissue would stick to primer, and it did. And it looks like what it is, it's a quick way to make a base for something. So I don't know. Just I wanted to do as many experiments as I could on this. But this certainly is ready for another coat of primer. I put 3 coats of clear dope on it, sanded them off, and you can see I've started to come through in spots. But it looks like the silk span over the carbon is a real quick way to build a base, rather than well, the thing with the primer is you got to keep putting it on, taking it off, putting it on. This, once it's on, you've got a layer of it, and it's a very even layer. So maybe we can use that technology in the future. Anyway, what I want to do, I want to notch out the back for the horn while that stuff's drying. I have a little bit of time here to work on these projects. I want to notch this out all the standard way we always do things. Not going to make a big deal out of that. And put a notch in here, notch this. Take care of the bushing in the back. We really only need the smaller of the 2 holes here, so all this has already been on the video. I'm going to do this because I'd like to I have a little bit of time today to run some things that I really didn't have time for in the past. That looks funny when you look in there and see the Nomex pieces. Anyway, it's on there, it's ready. Next thing we got to do is let the elevators dry overnight. But in the meantime, I have other little projects that have been on the back burner for a long time, and I have a couple hours to work on them right now. One project that's been on the back burner for a long time is I wanted to make, when we did Miss Ashley, let's back up a little bit, I wanted to have constant cord flaps. In other words, they were the same width, same as we've been making elevators. The reason for that was I wanted to see if there would be any gain or any loss in having them, but the flap was the same width. Now everybody that's involved in aerodynamics has a different opinion of this, but I have a real easy way of figuring out. I'll just make another set of flaps. But what I'm going to do is I want to make a set that's a little bit bigger at the root, and this is standard. This is the way standard flaps would be, and then take that exact amount of material and remove it here so that the area is the same. I don't want to change the area because that's kind of something that we've arrived at over a lot of experimentation. But the experiment would be if you took the area and added it at the root and took it off at the tip so that the area would be the same, would performance change at all? And the easiest way to do this is on a day like today when I have a little bit of extra time, just make up another set of flaps. Now, the thing is I want to combine this with another experiment. And the experiment, I know I can make Nomex flaps, and I know I can make other variations of flaps, but one thing I really did want to try, so I'm going to try to combine 2 experiments at once here. Now this is the experiment, and there's no reason to put a whole lot of this on video, but just to lay out what I want to do is I'm going to make up a flap to shape. And then I want to try to laminate on an ordinary wood flap, the normal way we make flaps. I want to laminate 1 layer of carbon fiber. Then I want to take it off, turn it over, again using the same thoughts that we had on the other part. Once it's laid over, and this side is laminated, so this will be a 2-step process. I want to lay the carbon on the other side, so that in effect what I'll have is, let me just move the sheet. I'll have a flap that has a little bit of a taper in it. I'm going to start with 3/4 of an inch, and this is really for my own information because I hear so many variations of what the aerodynamics of this are. But you never have to take anybody's word for it. It's just easier to make flaps. Now, once I have this, and what I'll try to do even, in fact, I'm trying to come up with a better way of doing it, is I'm going to leave the leading edge off, make the leading edge as a separate piece. This is stuff as I'm going along here, I'm trying to come up with ideas. And I'm going to leave the trailing edge a separate piece. Just a little cap of balsa, pretty much like the elevators. But the piece in between will have carbon fiber top and bottom and be a solid piece of wood. Now you think that's probably going to be a little heavier than normal flaps. Maybe it is, it probably is. But what I'm looking for is that they'll really be rigid. Really, really rigid would be a very interesting test, because then we could compare against the flaps that are on the plane now, which are rigid but they're not great, against some flaps that are really, really solid, and we could switch them right at the field. Anytime I've had a plane with a year of service, I always look around whenever I can for anything that looks like I could have done it a little bit better. One of the things I really never got a chance to do is test my, again, my experiment on the flaps. But I do want to make a set that will, and again, I'll just reiterate this, it'll be a ½ inch wider here, and a ½ inch less here. So in essence, we'll have more of that lift down at the cord. I don't know if that's going to make any significant difference. See, you never know until you actually try it. At least I never know. But when I look back at this plane, and because we're doing all this molding and we have parts all over the place, what I'm trying to look back and say, gee, I just don't know how much more successful in this you could expect. That plane that was built with all new materials, pretty much from the ground up. And I don't know that anybody ever made one, but it certainly has held up well. Another experiment, if we see gaps of time like this in the evening when there's not much else to do, I might make a set of elevators the same way, get more to lift. See, I wanted to see, the reason this plane doesn't have a rave rudder, I wanted to see if that tight fit was going to trap air in there, was going to be more effective, less effective. What really would be appropriate is make a set of elevators with a normal amount of gap in there. Again, when you can make things so quickly with the composite stuff instead of wood, that it gives you one more choice that you normally wouldn't have. But I would say this plane has held up very well. The few scratches and dings in it are my own fault. It's really been that, if you only could have realized how I dreamed about this carbon fiber stuff for so long, and finally got to fly it at the Nats and actually qualified right up in the top 5. So it was a relatively exciting year last year, but this year we want it to be even better. And any way you get things better, you got to be willing to pay the price for education. And in my case, I have heard so many theories. One of the other theories is about leaving the last 2 inches of flap not moving, tapering down to almost nothing like some planes have. Elliptical tips, we've built enough elliptical tips. But this was one of my thoughts that I thought would be real effective, because you can make this flap on a flat surface, and that was the selling feature. That was the big idea at that point in time. But anyway, we're looking to build on this technology. The idea is right now to take the best ideas from this plane and try to move the bar up one little bit. So the first thing I'm going to do, and I always fly these planes that have take-apart features. They have a pin in the hinge line, always with tape on the hinge line. So now when I want to go take the tape off, a good trick that John Brodak showed me, using a hair dryer, I'll flip it over on its little, look at this guy, get out of here. I'll flip it over and warm the tape with a hair dryer, just warm, not hot. That's a great tip from John Brodak, by the way. One of those tips that, and again I want to thank John for it, really pays big dividends, is to warm any of the hinge line tapes, or the Dave Brown tape, any of the ones you choose. It seems like a little bit of heat just helps release. You can feel the glue releasing. And I would never think about flying the take-apart plane without the hinge lines tape, because the hinge line gaps tend to get bigger and bigger and bigger. And also, it's a safety thing. If that wire ever loosens up, there's some part of this tape touching the wire, keeping it from rolling out. Especially the one on the outboard wing. Anyway, you can see how nice that's coming off. Then the residual, the glue that's still on there, can get off with M600. Sikkens M600. Things I like about making planes, and this is why I'm definitely going to make the Typhoon a take-apart plane, is, let's suppose you got to this point, you couldn't trim this plane out. If this plane were a little bit too heavy, I know, as an example, Paul Winter has a Tsunami that's too heavy. Well, you can always make flaps that are 1/4 inch bigger if you use this system. It's very easy to take the tape, it takes longer to take the tape off than the flaps. But this system, and I don't know who gets the credit, Paul Walker, Kaz, they've all probably
Probably you all copied it from the same person, and I don't know who that is. Anyway, somebody came up with this years ago because they've done this. I want to clean the hinge lines. And when I make the new flaps, of course, I have to put the other half of the hinge on here and then put the flap on. These act as the pins to line up my second set of flaps. I'm looking at this Brodak dope finish and wondering, it just held up perfectly. I'm looking, there's probably 2 or 3 little spots where I just touch it with touch-up paint and it'll be a brand new plane. Anyway, that's a nice feature. The other thing too, if you ever have a flap that's somewhere in the scheme of things is either too heavy or develops a warp, sometimes from being out in the sun, the flaps will bow. Any combination of these problems you can always work out if you can replace the flaps. It just seems like it wouldn't be a whole lot of extra work to make this recess in the hinges halfway on each side is the only trick thing to do, and then having to fly with the hinge lines taped. So it seems like that's a pretty reasonable trade-off to being able to just take the flaps off and go make another set, which is what we're going to try to do today.
The plane without the flaps, you get an idea of just how high aspect the ratio that Miss Ashley wing is, but that's a wing that very similar to this wing. And by the way, what would be cool, it's not going to happen of course, we could take the flaps right off the Typhoon if we didn't care what the tips should have a curve in them. Probably. Because they'll all be take apart. That's very, I don't know. If we wanted to do it this way, we'd have to use one master to line up this side of the hinges and then put this side to line up the Typhoon, but we're not going to switch flaps. I'm just trying to think of some of the other possibilities here. Leave him flapless and we'll just go out and cut out those blanks that we're going to use to make the new carbon reinforced hybrid flaps.
Cut the flaps, of course. I want to get a center line on everything. I want to make sure I'm working with straight edges. And what I'm going to do on this side is just run a piece of 1/8 inch tape up the edge and then sand this piece into the tape and sand this piece into the tape. Very simple way. It's worked for me very well over the years. And then I want to fit these to the plane and get all the angles and cuts and hinge pockets and everything in them before I put the carbon on. In the past, many different ways to do flaps. There's all kinds of jigs and rods and everything, but basically just laying out a piece of 1/8 inch tape right in the middle of the 1/4 inch. You can do it by eye. I think for our purposes and then by the way, this has always worked well for me. I've tried a lot of intricate ways of doing it. The reason I like the tape is I can feel it when I'm just getting down to the last few swipes with the sandpaper. This way that I've found to do this with a 26 blade and holding the blade on an angle, kind of an angle. Let's see if this wood has a nice straight grain. Sometimes you can get it to all come off in just 1 or 2 little swipes, but working up to the tape. Now if it was a little bit warmer outside, we could go do the sanding outside. We're kind of stuck with doing it in here. If you're lucky, you can get this to come off in one piece. Of course, you're never lucky, that's the problem. Now it's always easy to carve and sand one side before you flip it over, because then you have a nice flat piece to rest it on while you're sanding it. It's nice by having sandpaper on one side of this, it kind of holds it in position, and I can work off this edge and just, as soon as I feel I'm hitting the tape, I know I've got to go then to the smoother sanding block. I want to get one side perfectly flat before I flip it over and carve and sand the other side. Now once I pull this off, of course, there's a pretty good chance I have a decent starting point for these flaps anyway. Now next thing I want to do is lay out the front edge so I can put that bevel on.
I'm going to make this the same way I've made every other one. Pull out the first piece of 1/8 inch tape and then carve between this line and here, and then reverse it for the other side. And there's not much trick to doing this. We've only done this about 1,000 times, but there's always somebody that you can get it to come off in one piece. Boy, probably means you're lucky. I'll dress this off with a sanding block, reverse it, and do the other side. Now, the worst that can happen here is we don't like the way these flaps come out for whatever reason. We always have the original flap, so we will, in effect, have spare flaps to go with our spare fuselage. And of course, we have the tape as an edge. I'll reverse the same procedure on the other side, and we'll have our angle for the hinge line. Okay, the next fun job, and this gets a little tricky, but nothing we can't live without here. One of the things, I'm going to cut the piece of aluminum tubing, insert it right on there, and then cut a notch in the edge of the flap so that the horn itself will hold the tube in position while I do the final gluing. Now see, here's one of the things we need to keep in mind. We have really tight clearance here. There's no fillets on this plane, so this has to be kind of a precision fit in there. Having that piece already installed, and now just pulling the flap up here with the notch on it and tack gluing that in, that sets that at the perfect angle. To Dremel that little hole, that little notch, I want to harden that wood up all in that area with thin CA. Then I'm just going to put some slow dry in CA and let this just tack in place. I want to harden that whole edge of the flap up. The original intent here was to keep a nice tight fit up against the fuselage with no fillet. Okay, I'm just putting a nice edge here so that I can get a fine tuning right up against the fuselage. And that'll reinforce it with some nice C grain there also. Parts of this whole thing though I didn't think was going to be difficult was blending the tips in. And I want to harden this wood up, a couple of coats of thin CA, just let it soak right in. No kicker of course, and just sand that smooth. I want that wood relatively hard. I want enough clearance along here also, because this extra little piece is just a filler to take into account the curve of the body. If you happen to, which is what happened to me, while you're hardening this up, get some thin CA in that hole. Never take an electric drill or drill press and try to run it through there. Take the drill by hand and just carefully, because it's usually only, oops, there it is, usually only a little drop. With the flap just temporarily held in place with a piece of tape, I want to mark the exact place, the mirror image of where these hinge pockets have to be cut. And I'll make sure I label this that this is now the inner flap. I weighed them up and this is the lighter of the two by about 2 grams. And now that allows me with that little piece, now I know exactly where the hinge pocket, and I have that little tool, of course, I'll put that all in, and that finishes one flap. I just have to repeat this for the other side, and we're ready. Well, we finally have these all fit, the hinge pockets are in. I just wanted to make a test fit on here, make sure everything was free, because we have these so close to the fuselage. This one, I had to take a little bit of material away. I wasn't sure I was going to be happy with that. But the next step is to lay out the carbon pretty much the same way we did on the elevators. I'm going to do one side at a time. Make up my little Teflon boxes. And I hope this is good information. If somebody has a plane that's in need of a new set of flaps, or you just want to do some testing on your own, typically what happens is the heavier a plane is, the bigger the flaps have to be, and the more degrees they have to travel. The lighter a plane is, the smaller you can make the flaps, and the less they have to travel. So This will be an interesting test. Now we have more area. We have the same area, but more of it at the root, less of it at the tip. And when we actually get to the flying season, this will be a very interesting test.
To put this down, I thought, oh, let's try something a little different. I taped the Teflon sheet down, and I laid out, this is the last piece of big carbon we have. And what I want to do, I want to attach the carbon actually around the perimeter with duct tape to keep it from wrinkling up. And I have this frame built around it. Don't know if this is going to pay or if this is just a dead-end street, but what I want to try to do is get all of the wrinkles out of it, put it under just a slight amount of tension. Some of these things are easier said than done. This is one of them. Anyway, just to hold, try to keep the wrinkles minimized. I have no idea if this is how they do it in the real world, in the Boeing world, or wherever we are. Okay. The idea is that I'm not going to have any wrinkles in this, or as few. So, I can pick this up. You can see a wrinkle starting up at this end. I can pick up the tape. Now maybe this is going to be something I can use on other applications. The trouble is you never know what you're going to be able to use. Kind of, I'm thinking of this like making a silk screening screen like a picture frame. Now see, as I can kind of tack this down. Again, it can't be any worse than if I didn't do any tension. That piece there needs a little more. Still not perfect, so maybe this is not going to work. Anyway, I want to make sure I have room for these two pieces, because we're only going to do one side, and I'm going to have to come up with a way, some sheets of wood and some weights to hold these down. This is the part I've found to be real productive, is when this is just laying here and there's nothing holding it like a picture frame. It kind of gets hard to deal with. It gets unruly. Now I'm going, because I have Teflon on the table, I can just squeeze this right down. Because it's cool in the shop, I'll have a good more than a half hour to work on this. Pretty much the same as I did the elevators. I'm making sure everything is soaked, and then what I'm going to do is trowel, carefully trowel out every little drop I possibly can. See, this frame idea is what I had, and we're going to find more ideas as time goes by. I'm getting some ideas in my mind of how I want to do, because we're going to do that fuselage next week. The one thing about this molding technology is kind of a building block thing. Each time you learn something. Now imagine the first guy that built the first wood plane. Was it Miss Ashley? I don't think so. Think of how crude some of that early stuff was. Well, people would think that this is crude. Well, trust me, it is crude. Anyway, you can see how much, this is what I wanted to show, how much of this you can actually get off if you're real careful. Having that picture frame is a real help. And of course, this will have to sit overnight. I want to give it plenty of time to sink in, so I don't have any dry spots. You can pretty well get almost all of it up if you're really careful. See, because I'm using gravity. The gravity is going to pull us, we hope, pull it away from the wood itself, so we won't have those big globs on the wood. Okay, now the next thing is I want to take one flap and just see if I get a clean imprint. there's another area where it's nice that it's held down. Okay, and you can see I've got not a perfect match, so what I'm going to do, same thing I've done before on the other part. I had a brush out here. In fact, I thought this might be the way I wanted to do it, is just brush this side. Glob. I want to get it right up to the hinge pockets too, if I can. Okay. Now I bet we'll get a real good imprint here. Why is it whenever you say something like that, you know it's not going to happen? Okay. Okay, that's the imprint we're looking for, something similar to that. Now this side, I'm happy with that one side. I was just thinking of another thing I could have done. Could have put a little heat lamp here to try to thin out the resin a little more. But I think this will work. But each time I get one of these parts, figure out how to do it, I know I'm getting ideas that I can use on other little projects too. And boy, I look back at that first, you laugh if you have a copy of that, the first Spitfire cowling I ever made in a plaster mold, and who would have guessed it? Here we are years later. Okay. I want to make sure I get a plenty good imprint here. After a little cleanup here, this I guess is going to be the most important thing, is I'm going to put some wood on each piece and plenty of weights. I'm trying to, even at this point I can see resin squeegeing out of here. On. I'm going to take just some isopropyl alcohol and just clean any little dots off of this, because the weights I put on, I don't want to glue this West, I'm still thinking West Epon is like a glue, and it glues anything to anything really. So anything I put on here, I don't want to have a problem. If I have one drop of glue up there, I'm going to be able to, I can even clean this off the outside. So our little picture frame perimeter thing kind of worked okay. One thing we got out of this test. Okay, now obviously we're going to just let this sit overnight. See what that side looks like in the morning.
Well, it's Super Bowl Sunday. The people that don't live in the United States don't realize Super Bowl Sunday is like a big deal. I'm kind of a football fan, but not a fanatic, that's for sure. Look at him, he's got pound cake. That's our buddy Butch. Now we're going to have a kind of a little Super Bowl party. I don't know what we're going to call this.
Uh-oh, the house is on fire. And because New York team is in the Super Bowl, we're going to root for the Giants. However, we have that little bird downstairs who's rooting for the Ravens. I don't know, peeps.
Now we started our day off real exciting. Set the smoke alarms off in the house with our pancakes, but hey, I thought, for people that maybe don't know this, The first year Karen and I met, the Giants went to the Super Bowl. And we had our little Super Bowl party. Do you remember, honey? And today we're going to have a little party.
Just the two of us.
Just the two of us, and tell everybody what you bought. I won't put you on camera because you don't have your hair fixed, but how much pepperoni did you buy? We have more pepperoni than they have in Italy right now.
You asked for treats with pepperoni.
Oh, God.
So you got 3 kinds of pepperoni.
And I went down by Peeps' cage, and he's got a little sign hanging on his cage, Go Ravens. Peeps, you're supposed to root for the Giants. Oh, my God. Anyway. It's fun to if Peeps is rooting for the Ravens and they win, we're gonna have to eat humble pie from him. Anyway, all our epoxy's drying while we're waiting anxiously for the game to begin. I hear that chant going up, Go Ravens, Go Ravens. Anyway, if you didn't notice this is our pet mockingbird. We feed him every day. His name is Butch, and he's here every day, and he prefers pound cake over seeds and waffles. We feed him every day. Every day he's been here, right, Ken?
Oh, several.
He's a regular, we call him a regular customer. And he's rooting for the Ravens of all things. These birds. Do you remember our first Super Bowl party, honey? This was the game. They're reliving all the games. And they won it. We had such a Super Bowl party. But now we're more mature, we're older, and tireder and crankier.
Now speak for yourself.
We're just going to have 2 pounds of pepperoni and watch the game. Go Ravens, go Ravens. Who's going to root for the Giants today? Forget it. Go Mockingbirds. There's Super Bowl action going on here. Get out of here. Anyway, I wanted to show this. This looks like it has some promise. Now we have both sides. You can see one side didn't come out near as smooth because I had wrinkles in this. Now, the second time I did this, I stretched the material. You can see it came out a lot nicer. Now once I trim this, one thing I'm really impressed with. Now this is our rib structure. This is about as strong as a solid piece of steel. I can't imagine you could make that any stronger. That's incredible. Not sure what the weight is, and we're not really concerned with that right now. But the next thing is, of course, I want to trim off the edge. Now the other one, when I pulled it up, and they come right off of Teflon, of course. See what happened? I pulled the corner up. So what I'm going to need to do is get some epoxy down in there and laminate that back down before I go on to the next step. You really shouldn't try to peel this off. Well, it looks like what happened here is I have some dry spots where I just don't have enough epoxy. But see what the epoxy's done? It's actually delaminated the wood. That's how strong this is. I wonder, hey, I'm just thinking of something. See, because these are experimental parts, we can be real cute about this. I wonder if we can do this. See, CA really is one of the few things that bonds this well. Let's see. I guess we'll find out. Because we got to be able to figure a way of, if that peels up a little bit, that we can nail it back down. Now, I didn't get a chance to look at the flaps yet, but they're sitting over there too. Ooh. Yeah, that goes right through. Now maybe what's that? Ooh. That looks like it'll work for me to even lose my finger to it. There's certain jobs where the CA seems to work well at bonding. This may be one of them. I'm glad I thought of doing that little test. But anyway, you can see from having the material nice, so that's lesson number 1, is to get the Teflon sheet, or even better. Now we're at the point where we know these parts are going to work. Now it pays to make some tooling. Tooling being that I'll try to get a flat piece of glass and put PVA on it. See, then there'll be no wrinkles at all. All of this is from wrinkles in the Teflon and being sloppy. But now I know this is going to be, and I know, my God, this is strong. So this definitely is, well, If we had both sides like this would almost be, you could sand this down to be in a contest plane. Again, for a test piece, see, the side with the stretch Teflon really looks a lot better. But now I know that from this point on, the answer is going to be to do PVA on glass to get that nice smooth finish. And then there'll just be a lot less sanding. See, there's a lot of resin in this final part. And we want to be down. I don't want this. The resin isn't adding anything to this except weight. I want to be down into the carbon before I put the finish on this. One thing nice about trimming these parts too, you can just get in here with a pair of scissors. So we've learned something significant here, even though this is one side. Well, when we make these elevators, maybe we can make this the top side, the side you see, that looks real nice. But again, still doesn't even matter. On a test plane, we're not looking for best finisher woods. What we're looking for is try to come up with some new technology, something that'll be usable. And you can never have less. Now see, here's a little piece got wrapped around. This is, if you were doing final parts, you wouldn't want to see that. Look at this, he's going to eat the carbon. Go root for the Ravens, get out of here. Ravens. Giants. When I met my wife, our first Super Bowl party. And the Giants won the game, and I figured, hey, see if they lose, I don't know, maybe our marriage would have been doomed, but it's funny that some people really do think that way, too. I think their whole life would change if a sporting event went the other way. Anyway, we do enjoy the Super Bowl, and we will have a nice little party today. But that's now one elevator. For our we have to do our hinging thing and our horn thing and a final sanding, but that's pretty good. And I think the nice thing about this is skip the Teflon, just go to PVA on glass, because this will work. This will work for you every time. Doing to me. He's rubbing it in. Yeah, we'll see when the game starts there, Raven lovers. We'll see. Go Ravens. You gotta look at my flaps. That's what I want to go to. What I want to try to do is make the hinge line, you can see it's square, and dress everything off. I don't know how many operations. We probably could figure a way of doing this with just putting tape out on. Even having tape, it's really not that difficult to get it at least close anyway. One thing I'm surprised at is how easy the trailing edge rounds right off. I thought that might be a problem. But it doesn't take much to round that right off. But if we had both pieces with a really nice side, and that's where we're going. We're just going to better tooling. I'm convinced these experimental parts, these are going to be doable. And that is really nice with the wood frame in it. You can't believe how strong that is. Really nice. Next step in our evolution here is I'm going to try to take this piece of glass, and when I have some time, wax it I'll do it off camera. Wax it and coat it with PVA. Maybe get a couple other pieces of glass that we can use for, those parts are definitely going to be usable. I'm going to have to, see there's still some chunks of epoxy that slipped out here. I'm going to have to get I looked at this glass and there's just too many scratches and everything in it. So I'd like to get a brand new piece. But I guess the worst that could happen is, just thinking of ideas, I can get just ordinary window glass and glue it to this piece so that it stays level. We only need that surface, but the Teflon surface on a rib surface just leaves it not unacceptable, but it could be better. This part of this is going to be to put the little pieces of tubing on for the horn, and I have to inset that in. And this is our first real, truly composite. I guess it's a hybrid. There is still some wood pieces in here, but I'm convinced now that it's going to be worth doing the tooling. And I'm going to talk to Midgley about making up some flat aluminum plates and Teflon coating them so that we have a perfectly flat surface to work with. And I think this is really going to, when you do this, you don't know it's going to work. So you don't want to spend 200 hours making a tool and whoops, doesn't work. But I just have a feeling that these parts are well within, even if the stab is a little on the heavy side, but after I do the complete finish on it, I think some of that's going to go away, because every time I sand this down, it gets lighter. And the nice thing about this is it is nice and solid. I doubt if you'll ever have a See, now here's one of the problems that may happen. With the tail being so rigid, it may be that you have to make the body more rigid, because in the past the tail would bend, it wouldn't flex the body. Now with a stronger tail, but of course, we're not going to know that. We're not going to know any of this until we actually get this plane out on a flight line and get a bunch of people to fly it. Next of our things, because what I'm finding out is I need to have that perfectly flat. And I thought the Teflon would be close enough. Well, see, now the Teflon has a lot of advantages in making up a quick test part. But for a final, where I want that surface, I don't want to have even a pinhead in it. And see, that's one of the hard things about developing stuff. If you have an unlimited budget and you can just go out and have these tools made before you test them, well, great. Send me some money. If I got anybody who can write me a check for $50,000, this project will move right along. You'd also have to pay for a divorce and a funeral, because Karen would first divorce me and then kill me. Anyway, I want to see if this is going to pick up. Oh, I still have this piece of tape on. Because this is something that an average modeler can do. This does not get into that bowing tooling stuff. Now see, the finish on the flaps is a lot nicer because we stretched the Teflon, but there's still what I'll call imperfections. They're not really imperfect. In fact, this is better than I thought it would be. Maybe what I'll do is just using that same, see how flat that is. Maybe I'll just try reusing this Teflon when I do the other side. Of course, I have to trim these next. I'll do this off camera. Trim these next, flip them over, and do exactly the same thing on the other side, because this looks like... See, what happens with this is when you have one side done or the box incomplete, there's no advantage. You know, nothing's happening here. When you do the other side, it gets rigid in a big hurry. Anyway, more experiments. We'll get this done, and I'll put these end pieces in off camera, so that we, in essence, will finish up that stab before the Super Bowl starts. And see, all this stuff can be drying like time management. It can all be drying tomorrow after the Super Bowl party, once I sober up, and once I have my Ravens getting beat celebration. I don't think so, peeps. Anyway, what other? Yeah, I guess this Teflon has worked well enough. Or maybe you could even re-stretch it a little bit. I don't know. Anyway, this was just one of the things Dave Midgley's idea that worked real well for us. Now again, I know that once I put that second sheet on, how much stronger this will get, so we never know where this limit is going to be. And I don't know, when this is all sanded out, and then these flaps are usually, well, we'll see, labor intensive. This is a little more work, but I wonder, as opposed to all that sanding and everything, I guess we'll find out. And we will have an extra set of flaps from Miss Ashley. That's a nice choice. The key to one of the things that I'm learning as I go along, and of course, this is the kind of stuff you can't be born knowing. It's, unfortunately, you either have to work somewhere where they do this, or you're compelled, like I am, to do it on your own. One of the things I learned is if you take too much of this resin off, of course you get a dry spot in the part. That's not acceptable. And if you leave too much resin on, it either makes that you have to sand, because you have the resin sticking out on top of the actual carbon. So it's kind of critical to get, and I'm really, this is the kind of the thing that I'm kind of zeroing in here, how critical it is to get just the right, I guess it's like sanding a coat of silver. You want to get just exactly the right amount of epoxy on here to leave that nice straight skin. By the way, I spoke to Midgley since the last time we've been on camera, and I asked him if he could get me some aluminum and we could Teflon coat it. See, then we'd need no release agent. We could be working on, there'd be no wrinkles in the part, none of these little dots, these little things that are happening because of the Teflon. But it's just getting that right amount on that's critical. What I've found is, in my little testing, is it's real important to coat both parts and then scrape off as much as, you think, and again, that's that magic thing of how much do you scrape off. But if you try to do it and just lay one part down, you run that risk that you're going to get dry spots. So this has turned out to be, it's an education, just trying to figure out how much material to get on there, and then how much, in this case, I want to scrape it off. I want to get it right back on here. But how much goes on here? This is going to be the key thing to getting really nice. Well, I guess it's the key part to all good composite work. I'm getting ahead of myself here. Even in making a real composite airplane, is to get the right amount of resin to the right amount of cloth. We'll do the same thing of putting the weights on and trying to get as much pressure on that as we can. Now, I also thought of another thing that I didn't get a chance to test, and that's if I can put a piece of peel ply underneath this to force some of the extra resin on the surface out, because we certainly have enough on the surface here. Okay, those flaps are sitting under there, and we're just going to, we're going to go upstairs and have our pepperoni Super Bowl party. Go Giants! Who's going to win the Super Bowl, peeps? Who's going to win the Super Bowl? Go Giants! Gonna kill him. Win the Super Bowl. Just because Paul Walker wrote you a letter, don't get cute with me. Don't get cute. Go Giants. Ooh, he doesn't like the Giants. Go Ravens. Peeps has seen a bookie, he's betting on the Ravens. I don't know. I just remember one thing, and I just had to be reminded of it. 80 grit sandpaper, when you want to sand, if you're going to put any kind of paint on there. And a nice thing, this is not the kind of thing where you got to worry about going through on the cap strips. Now what I do is, after I get it, just scuffed up. I don't want to get it any light. The parts are plenty light. I just want to get a relatively smooth surface for that first coat of paint. Now with this all sanded out, I'm assuming this is going to be ready to ship off to Midgley to put onto the test plane. I would just think it just isn't going to get a whole lot more successful than this. This one went together real quick, and it's right here. It's about 74 grams. That's about. But don't forget, this doesn't need any paint. we'll be looking forward to seeing what this is like when he gets it installed in the plane, and we certainly have proven that there's a couple of new things that we've never done before, and that we can do them, and we can do them. Now, even though this tail might be a whole lot lighter, or maybe even heavier than its equivalent wooden part, one of the things we do have, you will never make a wooden tail this strong. I think this tail could survive a crash. And knowing Dave and Woody, we may get to see that. Anyway, it was a good experiment, had a lot of fun doing it, and I look forward to seeing this test plane when it's all put together very soon. Sports fans, it looks like Peeps knows more about football than Wendy here. I gotta go downstairs and congratulate him on a good pick. Oh, what? As I'm recording it, they're even scoring more. It's a blowout. Ravens beat the Giants. Oh my God. Even Big Dolly is not impressed. Anyway, never bet on a football game if you're a bird. Told you, bet on the Ravens. Oh, he's rubbing it in now. Don't you hate this? He's rubbing it in. Oh, Ravens. Peepster! Peepster, you're not supposed to vote for the Ravens. You're supposed to like the Giants. Oh, God. Anyway, we're going to be back to our projects tomorrow. This is drying, and we'll shed a few tears. Peeps will have a big celebration going on. Peeps. Peeps! Don't eat the camera. And we'll be back. I'd like to buy this sign. Send me $5 and I'll sell this autographed Peeps Go Ravens sign. See you tomorrow. Right, this morning, after a Super Bowl loss, I wound up putting a newspaper with the Ravens pictures in his cage. I hope you enjoy it, Peeps. Anyway, I want to peel these up. Ooh, they're coming right up. And it looks like we've got a real nice finish on both sides now. So what I'll do is off camera, I'll trim this all off, get this ready to sand, and get some, ooh, they're nice and stiff, nice and rigid. This is going to be real nice, I hope. Anyway, another good experiment, but what I've learned most of all from this is that the Teflon leaves too many little impressions in the part. I'd really like to come up with, and again, Midgley is going to try to work on a piece of Teflon-coated aluminum that we can use to release these parts. That's the next step in this. Now, because this is a permanent part that I'm going to use on a competition plane, I want to put a real nice finish on this. One of the things I noticed is before I actually trimmed all this off and did the sanding on a belt sand, I ran a thin bead of thin CA around the perimeter. Now what I did back here is every time I sanded this and did a blend, I ran a bead of thin CA along here. You can see it's getting kind of shiny, because what I want to have is some of that creeps under the edge and makes for a much stronger bond. The other thing is I want to be able to put that real nice final competition finish on that. Now, the way to get the weight off of this is still a little bit heavier than a wood part, of course, because we've got a lot of extra epoxy. And I want to sand down through this top layer of epoxy until I see the top, see what's happening. At the top of this, there's mountaintops, and then any extra resin, because of the gravity, just makes a sheet. So this is just resin on top here. I want to grind with 80 grit sandpaper as much of this off until I actually go down into the carbon. Now the nice thing about working with carbon, if you do this with e-glass, it's difficult. The hairs start coming up. With carbon, the hairs break off. So you really can get the thinnest amount, and it's the resin on top of the carbon that we want to get rid of, and that's a very, very important factor, because if you were to just leave it like this, all your extra resin is up on the top here. Now this other thing, and I spoke to Midgley a second time, all these little dots, when we get he's going to make a piece of jig plate with a Teflon coat on one side, and that'll we hope it'll eliminate some of that. But then what we'll have is a piece we can loan out to people so they can make their own parts or they can come to the shop here and make it, or bring their own material and make their own. And then we'll get to see if that's going to be worth doing. But the next step on this is basically about an hour or two of just sanding with 80 grit paper, 320, anything to get as much of that extra resin off as possible. And when you think of, if you're doing a traditional dope finish, how many hours you spend sanding, the fact that you're going to spend 20 minutes, an hour, half, I don't know. But it just seems like this might not be as bad as it seems. Find is handy when you're sanding this type of a shape, because here's what happens. If you try to sand it with your bare hand or a block even, there's not enough support. If you can support this, and of course I'm over the vacuum bench, and this is a legitimate 80 grit paper, and that's what anybody that does composite work and they need to make a bond of any kind, you need at least 80 grit to get sanding scratches in there. But to give you an idea how long, once the part is properly supported, and of course you could work with a block if you're more comfortable, is the 80 grit paper that lets it get a good bond. And you can see anything that's coming off here, this is basically all the extra resin, and I want to go down in here until I can really just get right into the grooves. And I don't have any extra. See, here's extra resin. You can see how much it's floating on top. And this is what will make this, give this part that will be down under what a traditional wooden flap would be with a full dope finish and the typical things that go along with that. Now, it may be that if we overpaint this, we'll be right back where we started. I don't know. We're going to have to go back and forth several times to find that out. Well, I just took an ink marker and marked the back of this so it would look more like carbon fiber instead of having a white. This is going to get painted to match the plane, but this is going to be exposed. And I was thinking in the trim, one of the things I can do, and we're at the end of this video, so I'm not going to get a chance to do it on this tape, is do the trimming where the plane normally is black. I can leave the carbon fiber showing through just as a little way of, I don't know, not sure I know if I like that yet. But I have 3 coats of clear brushed on it. Now see, it's not really enough to fill anything. I'm not going to get a chance to do the whole paint job on this tape, but just to see that once you get about 3 coats on, you can sand it out, and what it does, it fills in all the little valleys. And you can see here there's almost no valleys. You can see that. You could do this with primer if you wanted to, but I just think the clear, Brodak Clear, seems to work the best. And I brushed the first 3 coats on, and once I get this sanded, I'll spray them. And if I go through in any spots here, and probably I will, I'll just touch that up with an ink marker and then cover that with clear. Now these flaps without the paint weighed about 4 grams less than the ones that are on the plane. But I'm not sure if the paint is going to compensate for that. I won't know till I finish painting them and buffing them out and having the dope gas off. But they're certainly within the limit that we expected, and the one thing is they are strong, and number 2, they are straight. So we've just opened the door to 2 or 3 new possibilities here in the last time that we've been working on tapes. I hope you've gotten some information. I hope you'll share your information with us, and that once we get the test fly this plane in the spring, I guess we're going to find out. We'll be able to switch these flaps right at the field. And this is always the part that we like, is having interchangeable parts. There's going to come a time, and I don't know if it's going to be in the near future or far away from now, when I really would like to make up a carbon fiber wing for this plane. This is one of the planes. It already has a carbon fiber fuselage. We're going to probably, within this next week, now that this Super Bowl nonsense is behind us, we're going to be able to lay up our next Typhoon fuselage. Is sitting here with the PVA already dried. We're going to try to get some work done on Mike's Sato 72 Cardinal. So many good projects coming up. And now that we have all these 4-strokes in-house and we can compare them, and if we get some nice weather, we'll get to break in that laser. And we still have that Zetron. Well, I just can't wait for spring to come. See, this is like cabin fever here. And see if we're going to be able to use this, or if they're going to be able to use it even in other events, I don't mind developing as long as somebody gets the use of it. We really did learn in the course of this video is the limitations of using the Teflon sheet, but I'm happy to again say over and over again that this is one of the things we're going to be making improvements on. Dave Midgley is due to come down here in the next 3 or 4 weeks, and he's supposed to bring a nice piece of polished aluminum that's Teflon coated, so that'll give us the choice of getting much smoother finishes in the original part, much better than the Teflon sheet. But even so, this system makes usable parts, and you just can see the imperfections in it. Certainly a usable system. Now, there's not much to say here. We've done the finish on this over and over and over, this Miss Ashley paint job. But it's turning out to be rather routine as far as this goes. What I did find out worked well is to put about 3 or 4 coats of clear on the carbon parts to fill in all those little pock marks. That seemed like it would just made getting this final finish a little bit easier anyway. And we're going to find out once I get the whole finish done and the whole finish buffed out. This is going to be at least a week or so. And we'll be finished with that, put them back on a plane, and I hope that's going to be one of the things we'll be able to retrim on the next flying season, try to squeeze a little more out of this. And if it doesn't work, or if we're not happy with it, it's real easy. Put the other flaps back on. Or we have another choice. We can take these and use these for our guinea pig flaps and trim 1/8 of an inch more off, 1/4 of an inch more, trim them on more of an angle, less of an angle, add pieces to it. See, now we'll have having an extra set of flaps is always a giant advantage. I hope you've gotten some good ideas and something that you can apply right to your plane, in the very near future. Please share the tapes, and of course, as always, share the information. Spring is not far away here on the Jersey coast, and we look forward to getting out with Miss Ashley with the new flaps. Several other little things we're going to be doing as we have spare time available. That'll be a very interesting. As soon as the weather breaks, we will have some fun sessions. Think how much easier it is to do that than if we were to want to replace the flaps on a plane that was not a take-apart plane or didn't have removable flaps. And I guess that's the lesson to be learned. The lesson above all is make as many parts take apart as possible. In fact, I'm going to write something like that in the next Stunt News. Anyway, thanks for joining us, and we'll see you back at the shop on the next tape.